Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Faris bin Basri. My supervisor is Dr. Khairul Fazli bin Samad. My matric number is B0516101006. Today I will present about PSM2. It's about simulation analysis on power generate of thermoelectric generator device based on electrodeposited nanocomposite. Introduction. Thermoelectric generator is known as a seatback generator. Thermoelectric generator operate like a heat engine but are less bulky and have no moving part, transforming thermal energy into the electrical energy. Good thermoelectric properties of the material typically provide significant improvement in the efficiency of the device. The problem statement. Power costs are rising, environmental pollution and global warming are issues we are dealing with at this moment. How to calculate of power generated on the model TEG device will be carried out, and the value of several applied nanocomposite properties. We also need to predict the temperature difference when TEG is embedded with the investigated nanocomposite. The objectives for this experiment, for this simulation is want to evaluate temperature difference that can be harvested from TEG device that embedded with the nanocomposite material. We are using the ANSYS simulation ANSYS. The second objective is to apply dynamic flow parameter in the fluid simulation. So we running this simulation in fluid simulation in ANSYS. For the three is the calculate efficiency on the model TEG device. For the methodology, we start identify the problem statement, determine objective and scope. We research and literature review, and we collect data, and then we design the project in the SolidWorks. And then we take a material selection for our nanocomposite, and we preparing the simulation, gathering data and calculate for the efficiency for comparison, analyze the data and result and discussion, and this will be the end. That's my TEG model. This is a step for drawing to the simulation. First, we are drawing every part at the SolidWorks and assembly at the SolidWorks, and then we transfer into the ANSYS simulation. For the ANSYS simulation, we're gonna include into the fluid ANSYS. From there, we can set the airflow, and we can set the temperature from above, and from the top we can set the temperature, and from there we can calculate the different temperature we will be running. This is a nanocomposite that I use for the simulation, because we need the density, heat capacity and thermal conductivity to include our ANSYS. For the ANSYS can read the output can be reached for our nanocomposite. For the expected result, in ANSYS I can get the different temperature, and then from that result we can we compare to get the efficiency from the material, and I can compare experiment result with software analysis. From the software analysis, we have all the data we need. For the result, my winter first I using this material, this TEG in the house accessory. For the first A, we are using cooker using conduction cooling. From there, we can get the temperature for the conduction cooling will be released in 209.83 Celsius. And for the B, we using an electrical oven. The temperature will be reached in 127 Celsius. And the airflow, this airflow what will be happen in your house. For the first 0.1, 0.15, 0.3 and 0.8 meters per second. This is the velocity that we use. The airflow, the temperature I set for the airflow is room temperature is 26 Celsius. And this how do we calculate efficiency using a Carnot efficiency. For cooker using conduction cooling, from air velocity from 0.5 until 0.8, we can see the best air velocity for this cooker using conduction cooling is 0.5. With the P type using is SBTE, and N type PBTE, lead telluride. We can see the efficiency, the best of the efficiency is from there, from that material. The change of temperature, so we get 186.655. For electrical oven, we can see the efficiency is a very average. we can see all the efficiency can get from all velocity from 0.1 until 0.3 is 26, but for the velocity 0.8 he will drop the efficiency will drop to 2.5.4. The conclusion is first our objective to evaluate temperature difference that we can have with using a nano-composite material. From there we using the SBT as a P type and N type with BITE, PBT, SIJ and NIBITE. That's with the data from the material we input our 2 NCs to get the temperature difference we can calculate from there. And the second objective, apply dynamic flow parameter influence simulation. We are using the fluent NCs to get the simulation. From the picture we can see that's the parameter that I need to set before I can get running and get the temperature difference. And the third is the calculate efficiency on the model TG device. We are using the temperature difference and the formula we get and the formula to conclude to calculate the best efficiency that can be output from the device. Thank you. That's all for me.